Now that we've looked at tar, gzip, bzip version 2, as well as unzip and zip, let's turn our attention to the regular expression line processor, Grep, which is another popular tool that you'll use throughout your Linux, Unix, and text parsing experiences. We'll label this subsection, or primary section that is, Grep, which is a regular expression parser. And it features the ability to parse lines based on text and or regexes, or regular expressions. Now, so much of what we do with an Linux environment involves linear text files that may contain tens, hundreds, thousands, or even millions of lines. And we need a way, and of course Linux utilities provide multiple ways of doing so, to parse information concisely. So for example, you may be searching a document for only the keyword Linux, or let's say Red Hat, or you may be searching a log file for only entries logged by your VSFTPD server, or from the auth syslog facility. All of that can be easily handled by utilities such as Grep. Grep functions in that sense as a post processor. So indeed it is a post processor in that you can allow or leave your programs on Linux to log the way they typically do, which is in a linear fashion, and then post-process those text files using Grep, all without impacting the linear logging process. So with that said, let's move forward. Grep searches text files for matches based on what you specify on the command line, and a simple usage is as follows. Grep, and let's say there's a text file with Linux, the keyword in it, between single or double quotes. Search for what you're interested in, such as Linux, from the name of the file. Now we're going to go ahead and create a text file. We'll call it grep1.txt. And we'll do so in our test RH5 directory and populate it with entries that are worth grepping. So let's click on New for a buffer. The first line will be Linux, the second one CBT, let's make it capitalize. Third one will be training, and the last line will be Grep itself. Simple document will save beneath the test RH5 subdirectory, and we'll call it grep1. .txt. Again, suffixes are unimportant within the world of Linux, but we're accustomed to doing so from Windows. So to search for text from this document, here's a simple example. I want all lines containing Linux, the word Linux, in lowercase anywhere on the line. So it has the ability to parse lines and to return those lines based on the text that we search for. Let's navigate into test RH5, clear screen, then perform a grep search. So there we see it's returned one line which contains Linux, and the line was searched case sensitively. We should note searches case sensitively by default, which means we can alter the default behavior by turning on a separate option. Now let's alter this so that it does indeed search in a case-insensitive fashion by using the -I option, case-insensitive search. And we need to ensure that in the document we have an entry that is either mixed case or of a different case. So let's go with uppercase Linux. So from the shell, we'll alter the search, turning on the -I option. Now you see two lines have been returned, but again, if you search a traditional way, the case will be matched and the line is returned. Now whenever Grep has done its job successfully, and that is to return one or more lines, the echo of the exit status will return a 0 status. However, let's search for something that doesn't exist. A line containing Linux CBT. Nothing is returned and the exit status is non-zero. It's a 1 exit status. So if you're scripting grep, you can always search for an exit status of 0 to determine whether or not it's done its job or it has at least returned 1 match for what you search for. Now again, generally we search using grep using single quotes or double quotes, but you can also search without single or double quotes, and your search will be carried out for you in just the same way you'd expect, with some exceptions being when you use regular expression characters, you typically want to place them, or will want to place them, between single or double quotes, depending on whether or not there's any interpolation of variables by the shell. Single quotes are usually the safest when searching for data. They may search for numbers as well. If there's a line, let's say, which contains a number, let's create a line with 2, and return only that line. It searches literally for whatever you specify on the command line. And there you see it returns a line with 2, as opposed to the other lines. Now what if we create a separate line, such as Linux, CBT 3, or 2 for that matter, since we're searching for a numeric 2, then you see it returns both lines, which tells you a little bit about the way grep behaves, and that is, whatever you search for will be searched for anywhere on the line. So we did say it parses lines, however, it searches for the text anywhere on the line. So if your search string matches at the beginning or in the middle or towards the end of the line, grep will find it, and as a consequence it will return the entire line. Unlike other tools like awk or sed, grep will not return distinct columns of a line or distinct fields of a line using delimiters. It returns fully the entire line. If you need further parsing, then you want to stay tuned when we look into the awk utility to extract delimited fields based on a default of space. So again, the entire line is returned. Now, of course, there are more advanced ways we can use grep. For example, if you want to search for specific text at the beginning or end of lines, then you can use regular expressions or anchors. For example, suppose we wanted to search lines that begin with the keyword Linux, meaning, unless the line begins with Linux, don't return it. So we'll search grep1.text, and now we need to take a look at that data set to see what will be returned. If it's a case-sensitive search, which is the default, this line will be returned because it begins with Linux. If it's case-insensitive, then these 3 lines will be returned because the characters LINUX will match up. Let's take a look at that to see how it'll work momentarily. And again, this anchor, let's just note that, uses the caret symbol, or the circumflex as it's known as, anchor to anchor searches at the beginning of lines. Let's see how this behaves from the shell. And there you see it returns the sole line, or the line which begins with lowercase Linux. Case insensitively, of course, which would be option number 4 for us, grep case-sensitive search caret Linux from grep1.text will turn on a case-insensitive search. And there you see it returns lines Linux, Linux, Linux CBT. And this also includes mixed case lines, such as the following. Let's give this a try. Because it's case insensitive, the entire line is returned and not just the keywords for which we performed the search. Now how about if Linux exists somewhere else on the line, such as CBT followed by Linux? Based on what we've just mentioned, and that is that we're using an anchor which searches for the string at the beginning of a line, the final entry, or the final line which begins with CBT followed by a space followed by Linux, will not be returned. And there you see it's not, because it must begin the line, which leads us to the next anchor. Let's scroll down and just copy number 4, making a slight change. And that is, if you want to search for a string at the end of the line, we've got another anchor. That's a $sign anchor. This uses the $ anchor to anchor searches at the end of lines. Let's give this a try. This means if Linux terminates the line, regardless of case, then the entire line will be returned. And there you see in the case of, or the cases of, Linux being the sole entry on the line, as well as Linux terminating the line which began with CBT, then those lines are returned. So we see, for example, the first line Linux, second line Linux. We've skipped the entries containing CBT. However, although they seem as if they should match, they will not, because they don't end the line, and that's what the $ anchor is used for, to identify those entries which actually end the line. So you've got anchors. Now, anchors are regular expression characters. They're meta characters. You should just note that. Anchors are regex characters. They're also known as meta characters. They're used to match at the beginning and end of lines. And you'll use them quite often when searching any of your text files on your Linux system for specific pieces of information. Again, the nature of Linux programs is to log linearly, and the way you search through linear documents is to use tools like Grep in conjunction with tools like awk and sed by using pipes. Now, there are many other meta characters, of course, such as the period, the asterisk, as well as a question mark. There are also character classes which allow you to search for specific characters and ranges of characters. Let's take a look at that. For example, we know we have lines that have numbers in them. So supposing we want to search for lines containing just numbers, but we don't know what numbers exist. For example, let's add some more numbers. 3, 4, the number or the name for 5, for the number 5, and the actual number 6. So now we want to use, let's say, a character class. Grep, and in between single or double quotes will indicate that we're looking for a range, 0 through 9. You can be more specific. If you know the numbers are, for example, between 5 and 9, then indicate as such. But for our intents and purposes, we'll search for at least per line 0 through 9 from grep1.txt. And let's just give this a try from the shell to see which lines are returned. And there you see lines containing at least one number are returned. So this searches or returns lines containing at least one number. And we can confirm the output by comparing it to the items in the document. All of the lines containing numbers are returned. None have been omitted. However, all of the items not containing numbers are not returned. Now let's say we intersperse between training the number 1. We'll kind of bury it. Let's see if Grep can pick up on that and return the whole line for training. And of course it does. The first line it encounters, which matches the search, in this case training, which has a 1 embedded, is returned. Regardless of where the actual match is made on the line, Grep will be forced or is programmed to return the full line. Now, character classes can also be used in other ways. What if you want to search for lines that contain any number of text items, such as grep the following, and instead of 0 through 9, which will search for numeric characters, A through Z. Any number of A through Z characters. Well, first let's begin with A through Z so that you see how this returns. And we'll return to the shell. Control-Shift-V. There you see it returns lines containing A through Z, even if they include numbers. Lines that only include numbers are not returned. But what if we wanted lines containing any number of alpha or A through Z characters? In this case, also notice that mixed characters have been returned, upper, lowercase characters in that A through Z search. You can tack on a wildcard, which is a meta character such as $. $* will continue the search for any characters, or star against a given range such as 0 or more A through Z characters, or question mark 1 or more A through Z characters will allow you to search for those types of characters across the board. Now this is just some basic usages of grep. Some common usages also include using grep in conjunction with RPM. For example, your Red Hat system contains hundreds of applications. Even a default, a vanilla installation will contain somewhere in the order of 400 plus RPM packages. A quick way to parse through all the mess is to execute RPM query all, which enumerates the full RPM database of applications, but then pipe the output into grep. This we do quite often throughout our studies of most RPM-enabled OSs throughout our Linux CBC studies. So an RPM query all dumps everything to the screen, and there's no real way to grapple or deal with all these RPMs. This is just way too much information. It's still going on. It covers probably 600 plus packages. Well, one way to parse for something that's of interest is to combine your search with grep using pipes. RPM query all pipe grep, and then search for something that's of interest. Supposing we wanted to see, for example, the package containing grep itself. RPM query all pipe grep, and wherever grep comes up, it'll be returned. There we see that the grep program is more than likely a member of the grep package, grep-version 2.5, so on and so forth. So an RPM pipe grep searches the package database for programs named grep star, if you will. Grep followed by anything else. And you can do so for pretty much any program you have on your system. Supposing you wanted to know about the xorg packages that are on your system. Well, an RPM query all grep xorg will return those packages, and if you think that some of them may be in uppercase, then in your grep search, turn on case insensitive, and this will return any packages that are listed in a case insensitive fashion, but chances are you won't find any. If you want to know how many xorg packages exist, after you've searched for xorg, pipe the output into the word count program using wc-l, which will return the number of packages that have xorg in it, which tells us 86. So for example, RPM query all grep case insensitive xorg, piping the output. Yet again, this is the beauty, or part of the beauty, of using pipes, the ability to connect inputs to outputs. Case insensitive for xorg, piping the output to wc-l, returns the number of packages with xorg in their names. So that gives you a good way, or a good example of using grep on a prod system. Now, how about some production data, some logging information? Well, it's always a good idea whenever you interrogate logs to connect to the log directory as the root user, because many of the files you cannot interact with, such as some of those that you see here, like the messages file. The messages file is an all-purpose file that most programs will log to, and certainly programs that don't have distinct files will log to. So you can't look at this file as a user Linux CBT or any other non-privileged user. If we use less to interrogate it, it doesn't work. So let's su in. Now we're able to use less as a root user to take a look at the file, but this file is littered with all sorts of information. It's nicely formatted, so it includes timestamp information to the left, followed by the name of the host, where the message came from, which for most cases will be the local system, followed by the daemon that generated the message, followed by a message. Supposing we wanted to see all of the SSHD related messages, meaning anything related to the secure shell daemon, which may include people who have connected, any keys that have been generated, connections that have been terminated, so on and so forth. So establishments, terminations, so on and so forth. Well, again, this is grep to our rescue. It's very simple usage, but it really works, and I use it all the time. So you could grep SSHD, as we know that's how it's represented in the file as SSHD. That's how the daemon shows up, so no need for a case-insensitive search unless you think there may be entries that require mix or uppercase. But otherwise, you can trust that most if not all entries are represented with lowercase SSHD. So grep of SSHD from messages will do that trick. It will return all entries from the beginning of the file to the end of the file. Again, as we've mentioned, most Linux log files, Red Hat's no exclusion, stores documents or stores entries in these documents, in these text files, log files, in a linear fashion, from the beginning of time to the end of time, if you will, or from the last time the log file was rotated till the current time. So with that said, let's clear screen. And now we'll grep only SSHD messages from the document. And there we see entries from January 8th. And rather than counting each of the lines, if we pipe the output to WC-L, it tells us there are 4 entries between the period of January 8th and January 12th, because we've grepped the current messages file. And we haven't discussed logging. However, entries within varlog messages that don't have a suffix tend to be the active file. So messages.1, for example, represents a rotated version of, or the most recently rotated version of the messages file, whereas messages, plain old messages, represents the current messages file. So in our current file, which has data in it apparently from the 8th onward to the 12th, we see that there are only 4 entries for SSH, but grep is able to extract that information for us and make it visible so that we can cut through all the mess. Again, the messages file contains myriad data for myriad services, ranging from SSH to audit to syslog for general messages to gconfd. You know that you're likely to find it in this document, and grep helps you to parse through that mess. But again, be warned that, or be forewarned, that grep will return the entire line as represented in the document, which includes the full timestamp in this case, the host, the daemon, plus the process ID of the daemon that was connected or running at that time, plus the full message from the daemon. In this case, it thinks, or it thought, it was a possible break-in attempt from the connecting user, and grep has returned that information to us. Now again, we mentioned grep supports meta characters, character classes such as 0 through 9, A through Z, case sensitivity using -I, and mentioned the meta characters asterisk, question mark, and dot to represent the number of times a specific search should be performed, so on and so forth. Those are some of the ways you can perform your search. It also has an inverted search, which means search for everything other than what's specified. So if you wanted to see from the log file everything but SSH messages, for example, and by the way, no need to memorize all this stuff. Grep --help will return the options that are important to you, and in particular, the V option is the key option that we're interested in. That's the lowercase v, because uppercase v is for version, or long format version. This is an invert match. So what this means is as follows. If we wanted to extract all but SSHD messages from the messages file, then simply include the lowercase v option. This performs an inverted search, which in this case means all but SSHD documents, or the SSHD entries in this document, will be returned. And this comes in handy quite often, because you may have a log file that's overwhelmed with information from a specific daemon that you want to exclude for your intent and purpose at that particular time. So you may want to not see items related to SSHD. So invert the search. And now we see items other than SSHD. Or perhaps we don't want to see gconfd. Now we no longer see gconfd. And to stretch this out a bit, this is where piping can help us out. Now supposing you don't want to see SSH messages. You also don't want to see gconfd messages. So grep v SSHD messages. Once the output's been created, then pipe the output again back into grep with another case, or inverted search that is, for gconfd from the input stream, and you'll see that both types of messages, SSHD and gconfd messages, will be filtered. So this is an easy way to achieve your desired result using simple Linux commands like grep, awk, sed, so on and so forth. Run it once, and let's just do it one at a time. Run it once, you no longer see SSHD. Run it twice, you will no longer see SSHD, as well as gconfd. Let's just clear screen and do that again. Now you see only other items such as syslogd, auditd, a troubleshoot message, and so on and so forth. So you can combine as many of these as you need or see fit to avoid having to parse through superfluous information in a limited console window. Grep provides that option. In addition, as we mentioned, you don't have to remember all the options. Grep --help returns them for you. You can print a count of the matching lines per file by turning on the C option. So after we've run through all of this, you could turn on -C, for example, and instead of returning the entries, it tells you how many lines have matched. So even for a simple search, grep SSHD for messages, this will tell you how many messages entries are SSHD, or even, let's say, gconfd or auditd. Let's try auditd in this case. There are 2 entries that are auditd. You may want to do a context search. Sometimes when I'm searching through, let's say, especially a mail log file, you may want to see or extract a specific item for however many occurrences and items around that item. That's a context-based search using the uppercase C option. So you can see a snapshot of entries around the entry that you intend to dig deeper into. So for example, grep uppercase C, SSHD from messages. But when you specify context, you need to also indicate the number of lines around the entry that's extracted. So this returns 2 lines above and below matching line. Again, this gives you a great idea as to what's happening at the time of the entry that you're interested in, especially with mail logs and security audit logs that are produced by the auth facility, like for SSH and connecting via Telnet, FTP, so on and so forth. Someone may have logged in at the current time. Let's say we extract from the document 1650, but we may want to see items that are at 1648, 49, and 1651, 52, so on and so forth. Well, that's where a context-sensitive search becomes very handy. So in this case, we'll see SSHD with multiple items around the SSHD item per hit, and it gives you a sense for what's happening around that particular interest. Because again, you got to think of log entries in Linux as being linear. Let's just note that. Note, most, if not all, Linux programs log linearly, which means one line after another in a sequential fashion from the earliest date to the most current. So from the earliest to the current. And as a consequence, you're often searching from the top to the bottom of documents, which is why tools like head and tail become so handy, so useful. The ability to see the first few items, the last few items, perhaps middle entries and surrounding items using grep makes these tools invaluable. And that's where grep can help you to excel. Now again, regular expressions are best specified between single quotes. So note, use single or double quotes to specify regexes. Also, execute grep using egrep, which is the regular expression form of grep. So execute grep using egrep when regexes are being used. Although the regular grep will recognize some of the regexes, especially the basic ones. If you do a which egrep, for example, you'll see that it is in bin as egrep. Let's just take a quick look at it. And it really links to grep, but it calls grep with regular expression search turned on, such that when some of the items that would fail normally with grep, when you execute them with egrep, some of the meta characters in particular, will not fail when you execute grep using egrep. Or if you execute grep with regular expressions, if you run it with the E option, that's another way to instruct to grep that you intend to use extended regular expressions. So in this case, extended regexes, or just normal regexes using lowercase e. Grep supports both POSIX as well as extended regular expressions, which is POSIX form as well. Not as much functionality as what you'll find with Perl, but enough for you to perform some pretty useful searches using the dash lower E or the dash upper E, followed by some of the types of characters that we've mentioned, like character classes, as well as meta characters like asterisk, dot, question mark, plus, so on and so forth. So, just to recap, grep is a line processor. Whenever it matches an item on a line, that's a hit. That's a zero exit status, which causes grep to return the line. If you need to further cut up or segment that data, then you'll need additional tools like awk and sed, which we'll be looking at subsequently.